All right. Good morning, everybody. It is June 7th. This first hour, I wanted to go over real quickly, go over um, some solutions. There's more than one way to solve a problem, certainly uh, more than one way to format these solutions. So that's the first thing I wanted to make sure that I said is that don't think I think that there's that these are the optimal solution or the only way to solution. And a couple of them are from you guys directly. So shout out to folks that turned this in. Everybody turned it in. Um, uh, but you'll see if you see your work, feel free to jump in and say, "Hey, that's my work." uh, there was one in particular. I think it might have been. I can't remember if it was Kevin or Edgar. Some particularly good work with uh, try and accept, some exception handling if people entered the wrong data, but I don't think I was able to paste that in here. So anyway, we'll get started here. First one, taxi fare is pretty straightforward. One thing I saw folks doing was um, getting the distance traveled in kilometers and then dividing it by 1,000 to get it into meters, but then that caused kind of a math error. So um, for the solution for this one, so we need to get them to enter a distance in kilometers, and then just divide that distance by 0.14 to get um, the partial rate. So the base fare is $4. So no matter they get in the car, it's going to charge $4, and then it's going to add $4 minimum, and then even if they only travel 1 kilometer, it's going to add that partial rate of a quarter per 140 meters traveled, which if you do the math, it's like 7 1/3 quarters per kilometer, something to that effect. So anyway, there you go. If they only go, I'll hit control and enter to execute this code cell. If they go, let's see, 2 kilometers, it does the math. And so you get the $4 plus another $3.57 in the distance traveled additional surplus. I'm not going to post these yet because, like I said, we got Jeanette and Alyssa joining us today, so they'll be able to see it on the screen. But I'm not gonna post these solutions until they get a chance to take a shot at them. Okay, and this next one, I think this was one of y'all's work. Does this look like either of y'all's, the three of you, your solution? I would swear I got this off of one of y'all. I like the way you constructed it. That you,
Not
Kevin?
mine. Nah, because I didn't check for how many letters there were.
Ah, there you go. So yeah, so we get them to input using the input function. We get them to tell us a letter, and then I could have swore it was one of y'all that wrote this way. Could have been a
It might
previous.
be mine.
Seth, does that look like you? Okay, because what the author did, I believe it's Seth, is take each type of letter as a case in an if, elif, else block that pretty much covers the gamut of what the single characters that they could put in. So input returns a string. That's the thing to always remember, is you're always dealing with a string coming back from input. Check to see if they put in more than one, and then it won't. If they put in two characters, it checks that first if and comes back out to the next blank line if it satisfies that condition. Remember that about if, elif, else. Once it satisfies one of those conditions, it doesn't check any subsequent conditions. So you can order those elif conditions in the right order so that you don't have to do a lot of, you can avoid some complex logic if you get them in the right order. But I think this one's fairly agnostic as to what order you put them in. But I like the checking the length first. That was good thinking. So, and then otherwise, we're using a string object method called isAlpha, which returns a true or a false if it's an alphabetic character, regardless of case, lowercase a through z, uppercase a through z. If it's alpha, it returns a true. So Seth said, if it does not equal false, which equals true, so uh, letter's not a letter. And then the lower method of the string case just returns the lowercase letter regardless of what case it was entered in. If I'd entered a capital Y, it would return the lowercase value of that. And of course, Y is so that avoids you from having to say if it equals lowercase y or uppercase Y. That's brevity. It's more elegant solution. So we say Y, sometimes a letter, sometimes a constant. And then we check we use the lower method again here to check to see if it's a vowel. And then we say it is a vowel. And then otherwise, we're saying it's a consonant because we've already covered. If we put in a special character, if you put in, a plus sign or a minus sign or whatever, he's already covered that in the isAlpha. So go ahead and get rid of the errors early in your if elif block. So I thought that was a good solution. Okay. Next one, we're calculating an average. And this one is just entering values, numeric values, until they enter a 0, which is your classic sentinel value to end a loop. So we're instituting a list. I think this is one of y'all's also. Just look familiar.
I think this might be mine again.
Could be. I probably graded yours first, Seth, and went, yep, that's a good solution. Let's pound that in there. Because I've done these and helped students and worked on it. And I've got so many different versions of this that I've lost track. So once I saw one of yours that looked good, I thought, hey, let's give homage to the current group. So there you go. So we're instituting an empty array, an empty list with this value list equals and then the square brackets. We're initializing a floating point value average equal to 0, and a couple of print statements just to let them know what's happening with the program, and then float input. So we gather the input on the inside. Remember, you work from the inside out. Gather the input and then convert it to a float. So we're working with floating point values throughout the problem. So if they enter to 0 initially, we'll print out an error message. Otherwise, else : we'll do this block down here. So we've got a nested while loop within the else branch. So while they haven't entered a 0, because they haven't yet, we've already checked to see if the value is 0. So it will execute this loop at least once. So while value is not equal to 0, we're going to add that value to the list using the append method of the list class of a list object. So we're going to add value to the list, and then we're going to get it, and then get another value. So it will look to the user like it's the same input statement because it's the exact same verbiage. Good morning, y'all.
Hey, good morning.
All right, let me get through this here problem, and then we'll let you introduce yourself. Okay, so we're just adding the value that they put in there to the adding it to the list. And then you could, some folks did in the in the loop here. You could accumulate values. You could add each value to a running total, and you could have a counter that would count the number of times through the loop, and then you just divide the sum of all those numbers by the counter. So some folks did that, and that's a good solution. The I like this using using mathematical functions or built-in functions. So sum will sum all the values in a list, and length will give you the length of the list, which is it's more elegant, I think, than keeping those counters going. So good solution. And then we just print out the average and format it appropriately. .2f is the 2 decimal places. So I thought that was an elegant solution. So Seth, did you concoct that in your head completely alone, or did you find an example on the web? What was your problem solving approach to that one?
I mostly just worked through it bit by bit, like deciding what I needed to do. Now for things like the append there, like I knew what I wanted to have happen, and I had to look online to figure out, to like find how the command to make it happen, right? Like I knew I wanted to add items to this list. So what command adds items to this list? I had to look up that sort of thing.
And what function returns the value of a list? Because there's probably a method, there's probably a list dot length or something like that that's an attribute of the length. So or there's the built-in function. And to me, with Python, it seems like there's always more than one way to do something. So the fact that you know something can be done, and you just go out and Google, or choose your method of learning, but you just go out and find out how that tool does it. It's going to be different syntax in Excel, different syntax in DAX, Python, SQL, and I can't remember any of it. So I'm constantly Googling what it is that I am trying to do. If I'm in a tool using it, frequently, I'm okay. Other than that, my head is just swimming with language syntax and ways to do it. So I wind up having to search for everything. So anyway, before we move on, this is Python Problems 2, number 4. Before we move on, let's welcome Alyssa and Jeanette. Guys, if you'd introduce yourselves, a little bit about yourself, what brings you here, where you're working, all that kind of.
Yeah, I'll go first. I'm Jeanette Adams. I'm originally from St. Louis, Missouri. So if you're a huge Cardinals fan, we have that in common. But now I'm here permanently in Fayetteville, Arkansas. I went to school at the University of Arkansas. And now I'm here working at a firma, which is really awesome. It was me and Alyssa's first day yesterday. And we're here just kind of getting some more training on our job. That way, when we start taking clients at a firma, that will be perfectly equipped.
Cool. And
Jeanette,
yeah. What was your degree program?
So I was a dual major in information systems and then finance as well.
Oh, okay. Nice to meet you.
Nice
again.
to meet you.
And Alyssa?
Hey everyone, I'm Alyssa Hernandez. I'm originally from the country of Belize in Central America. I graduated with a degree in information systems and a minor in business analytics. So I'm here to brush up on my analytics, see if I can learn anything new, hopefully, so that, like Jeanette said, we can be better equipped to handle our new position here at Affirma Consulting.
All right. Great to meet you too. Welcome to the course. There's 6 current students. 2 of them work as SQL database process analysts, monitors. So they work with overnight batch processing of financial data coming out of I think they're servicing Simmons Bank, but they work for a company called People Shores. Real quick, Seth, would you introduce yourself?
Yeah, my name's Seth Turbyville. I'm currently working at Bumper to Motor Auto Parts as the marketing analyst. I do a lot with their promotional programs and tracking different things like that. That's what I'm doing right now.
All right, Kevin.
Hello, I'm Kevin. Also a Regent graduate. Currently, I'm working at Department of Environmental in Little Rock. Really as like the system administrator, but also like the internal software developer. And I work with like this program or software as a service thing called Intellects, which is like where clients come in and put in their data. So that's where the data analytics coming. Yeah.
Okay, I heard most of that, Kevin. That audio wasn't super. I'm not sure if you can get a hold of one of these inexpensive headset booms when we do the Excel project. I'm going to put y'all on the spot and have you present. So that might make for better audio. Edgar, would you introduce yourself?
Yeah, can you hear me?
Yeah, clear.
Okay. My name is Edgar. I'm originally from Panama. Graduated in 2018 with a information systems degree, and I currently work at Shallow Technologies in Rogers as a data analyst. And that's pretty much it.
Okay, and then we've also got Chris. Chris works at Southern Bank Corps, Team Walt. So yeah, a couple of folks in the financial sphere there. And then Cameron and Dexter are the two SQL analysts I told you about. They work shift work and aren't able to attend in real time every class session. So you'll run into them. I'll make them introduce themselves when they're in session. So what we're doing here, guys, is our second Python. This was once we had covered if then else and looping, just a few brain teasers to get into the syntax of Python and get a little bit more familiar. So that's where we're at now. The second hour, I'm going to go over our first Excel project, which is really just free form, have fun. You'll see. Just I'm not going to inflict a topic on you, or this isn't college. So I don't put out, like specific quizzes with true multiple choice answers or any of that sort of stuff. It's a whole lot more hands-on, like you would expect in more of a corporate environment. So if anything that I assign is confusing, please email, text, call, anything, and let me square it away. Okay, so this number 4 was a temperature conversion chart to show Celsius between 0 and 100 degrees in increments of 10, and then compute the appropriate Celsius next to the side of it. So the formula's right there in the markdown cell. You guys haven't seen Jupyter Notebook, Alyssa, Jeanette. This is real quick. Let me back up just a little bit. This is Jupyter Notebook. It's an interface to Python, not the only one. You can work in a traditional scripting. You can just use a text editor and then run it from the command line. So you don't have to work with Python like this, but it's very it's a really flexible and effective environment for things like this. When you're prototyping or you are developing a teaching aid, there are multiple textbooks out there that are developed on Python or R that are developed in Jupyter Notebook and then rendered as a PDF. They do the whole thing in this environment. So like up here, this temperature conversion chart, there's 2 types of cells we work with. This is a markdown cell. So you've got all, converting language, kind of like HTML, to format your documentation cells. Pardon, but they don't execute code. And if you, but if you want to execute the markdown, you either click on run up here or on the keyboard, just control enter, and that will execute the markdown and convert it back to the pretty format. And then for a code cell, you click inside of there and it's the same thing. You can click the run button up at the top or control enter and it will execute the Python code. So here we've got a couple of assignment statements, our Celsius and our Fahrenheit value. We print a header one time across the top, and then a blank line, print with open parentheses, a blank line. And then we have our column headers here. The literal string and a print statement of \T is a tab character. If you guys haven't seen that before. So that'll automatically make the columns line up real nice. And then we do a for loop. And Python uses, I'm going to want to go back, Alyssa, Jeanette, I'm going to want to go back and just cover Python syntax for that we've covered up till now. So this won't be the last time you see it going over this homework. But we use the range function in Python instead of directly telling the for loop what numbers to use. And the range function takes that first parameter is where to start, up to but not including parameter number 2, up to but exclusive of the second parameter. And then an optional third parameter is increment by how many. So we're incrementing by 10. So inside of this for loop, and you always got to remember your colon. I forget that all the time and get an error, and then I go back and put my colon in. So that signifies the beginning of a block. So these 2 lines of code will execute 10 times. Remember, up to but not including. So if I just put 100 in the second parameter, it would have only shown me the temperatures up to 90, because the way the range function works and the way the for loop works, it would not work if you put 100. That's another bug I probably programmed in the first time. And then we're setting Fahrenheit equal to, and remember, we always work from the inside out when it comes to parentheses. So we've got some math on the inside, the formula for converting Celsius to Fahrenheit. So we'll do the 9 divided by 5 first, then we'll multiply it by the Celsius, then we add the 32, and then we convert it to integer. You'll find, Jeanette, Alyssa, you'll find that Python and data typing are a constant source of joy and frustration because it does things automatically that you might not be used to with like C++ or Java. And anytime anything's doing for you automatically, you gotta, it thinks it's helping, but anyway, so then we print out our table for those 10 times that we go through the loop. And there you go, 0 to 32, and then 100 degrees Celsius, 212 Fahrenheit. I was listening to I don't know, Australian or Canadian stand-up comic talking about crazy Americans still using this Fahrenheit and miles and all of that. Why don't you use the metric system? It's too hard. All right, and this last one is fairly complex for a first Python program. So what we're doing is gathering the ages of standby. Beg your pardon. We're gathering the ages of a group of folks that are coming into the zoo or a park, or a zoo. There you go. And then based on their age range, we're assigning the ticket price, totaling that all up and telling them what their total is. And these are like typical brain teaser programming problems out there. Probably not something you would necessarily code directly like this, but it sure gets you into the syntax of the language. So for this one, like I said, somebody did a really good job on one of these of doing exception handling. We may cover that in a future one. Alyssa, Jeanette, generally speaking, I teach and use Python up to the point where it will work, but I don't put a whole lot of time or effort into making things user proof, like, because I'm the user generally, you know what I mean? So I know not to be delicate. I know not to put in the wrong value, but in the real production environment, you would put a whole lot of work into handling bad values, exception handling. All right, so in this one, we're setting a party total, which we know will be a counter, and we one time initially, you virtually always have to do this if you're going to run if you're going to be gathering a list of things or a group of values. You always have one outside of a loop, and then you go into the loop, and there you go. So we're going to get the customer age, and this is the first customer. And then we're using the is numeric method of the string class. So it's going to, you could put enter customer age, you could put Bill in there, and that's not numeric. And so before we try to turn it into a number, we check to see if it is numeric. So, and if it is, if they entered numeric characters, we can convert them to integer. Okay, and then we do a while loop, which is the other kind of loop. So it's a condition-based loop where it checks before it even executes the first time, that condition has to be true. And then inside of that loop, you better do something with customer age so that eventually this loop condition not equal to an empty carriage return, not equal to null, will at some point, that condition will be true, or you will write yourself an endless loop. And we've all done it. And if we haven't, we someday will soon, working with loops. Okay, so while the customer age is not, a null, which I don't think we would have been able to really get there yet. If customer age is greater than 65, so the way to handle this is, since there are pricing tiers, is to you don't have to use compound logic. You don't have to say if it's greater than 13 and less than 65. If you order your if, elif, else, if you order your cases appropriately, you won't need that compound logic. So we add $18 if they're over 65. Otherwise, we check to see if they are over 13 years old, and if they are, we'll add 23. But since we've already checked to see if they're over 65, it's going to check to see the people that are 13 to 64. That's the importance of ordering these elifs correctly. Otherwise, we're checking to see if they're over 3. And if they're 3 up to 12, we're going to add $14 for that rate. So we're then getting the next person's age. See, we already asked once, but inside the loop, you got to ask their age again and use the same logic to see if they are entering a numeric character, and if they are, we change it to integer. And if that see, we don't want to try and convert just hitting enter, because that's the end of the loop. Is when you're done entering ages of the people coming in, you hit enter, and it will check for that and bomb out. So you don't want to try and convert a null value to integer, or you'll get an error. So that's good to put that check in there that it's numeric. And you don't want to try and convert an alphanumeric or alphabetic string to integer, or again, it will error. Okay, so we do that loop until the user enters a null string or enter, and then we tell them how much they owe us. So I'll enter that again. Customer age is, what's the next bracket? Old, and then young. And then if I hit enter, it terminates the loop condition, and we get down here to our party total, $55. And we could format that with the formatting string. That's the other, Jeanette, Alyssa, these guys have heard me say a dozen times, I don't really work with making Python pretty. I don't do reporting with it. I use it for teaching and my own projects when I want to script something. There are pages of documentation on the print function as far as getting it to work out right. And if you are doing traditional old school reporting with Python, and that's going out to an output file, and you want columns to line up and everything, then that is absolutely something you would want to get into. Okay, did I confuse anyone? I want to thank the folks that turned in elegant solutions because I included them here. How we doing, guys? Jeanette, Alyssa? Okay, like I said, this Jupyter notebook up. When you guys get Anaconda installed, when you both have Anaconda ready, shoot me an email and let me know. And we'll get together real quick and go over my notebooks that we've covered so far and that environment and everything, get you caught up. Okay, so that was Python Problems 2. Okay, well, before I launch into the next one, let's take 10. Cell phone time. Yeah, 9:15, close enough. And we will resume and I'll show you this Excel freeform analysis project I wanted to do. Come back at 9:15. All right, welcome back. Second hour. Okay, so this week I would like to devote some time to using Excel to analyze data and presenting that process in a methodical fashion. So the first thing I'd like to do is go back to one of the first presentations that we worked on, one of the first discussions that we had. And that was in a PowerPoint. Not that one. Here we go. In the world of data, I want to bring up a slide. So let me share my screen. You'll all remember this. This is the data analytics lifecycle. And when you're presenting this Excel project, and we'll do it again in Python, May probably won't do a full project in Power BI, but your final capstone project needs to more or less track with these phases of an analytics life cycle. So as I go through my presentation today, I'm going to try to frame it so that what I have done tracks with these more or less with these 6 phases of, you always start out with an objective. You always start out with something a business issue, a question, some sort of objective for your analytics. And then figuring out what data is available that could address that, grabbing the data, doing some transformation. I'll pull up Excel and show you what I had to go through. Data enhancement, that's kind of more big picture, as far as having to modify your information systems to provide more information or more data fields than you may have currently. And then you run it through your analytics, whatever that's going to be, present the results in data visualization, and then around and around and around you go. So, like I said, my presentation today will more or less mirror this process. And I'd like for you guys to emulate that as much as possible. So let me put that away. And hang on. Don't need that tab. Don't need that tab. Okay. Share screen. All right. The whole screen, nothing but the screen. Okay. So I will start off in PowerPoint, but then I will pull up Excel as well. So let me pull up the PowerPoint. DAAT's U.S. States Research Project. And I'll put it in the background, but let me pull up the Excel as well. Okay, so first, I'll use my PowerPoint because I need to tell you my objective, right? That's the first thing you do in any data analysis project. So my research question, what I wanted to figure out, was there a relationship? What relationship does, if any, does a state's per capita spending, the state budget, have to do, what's the relationship with any other measurable factors? And I could have gone nuts with this. There's so many, my mind went down so many different trails. But for this assignment, keep it manageable. Depending on how curious you are and how much data is available in whatever you decide to work on, you can get yourself spun way out of scope of this little project. So remember, I'm giving you what, I'm going to give you like 3-4 hours total to go find your data, bring it into Excel, and then prepare your results for presentation. So don't let yourself put too much scope on yourself. Okay, so the three other factors that I looked at were violent crime rate. It's a number of crimes per 100,000 people. High school graduation rate as a percentage, and gross domestic product per capita GDP, to keep apples to apples, per capita GDP, which reflects in other way, poverty levels, all of that. But I wanted to look at public spending, because you'll see here in my little blue bumper sticker at the bottom, I was doing my income tax earlier this year, and I just so happened to also get my personal property tax bill at the same time, and I thought, man, Arkansas's. I met my wife here in 1984. Arkansas has always been kind of my second home, but I grew up in Florida, and they don't have an income tax there, and they don't have personal property tax. And I've lived in Texas for 6 years, and they don't have an income tax or personal property tax. And Arkansas sales tax is really high. So that got my wheels turning. So this was something I was actually curious about, which I would encourage you, whether it's sports or public policy or you name it, entertainment, whatever you choose to use your time on, I would encourage you to do something you're interested in. So yeah, so I'm thinking, okay, so we pay a lot of taxes. What are we getting in return? So that was the genesis of this part of this uh, this project. And that was just this year. Okay, so the next phase in a data analytics is you figure out what data is out there, what you have to work with. Well, luckily, there are lists of U.S. states and territories available on the web that are focused on key issues or myriad issues. I've been unable to think of one that didn't have a table somewhere to provide the data that I was looking for. So I thought, okay, well, if we're spending a lot of money, maybe we're spending it on education. We got higher education rates, maybe, we're spending a lot of money. Maybe we're spending it on fighting crime, and we got a low crime rate, or we're spending more because we've got a high crime rate. But one way or the other, I was thinking there'd be a relationship there. And then, if we're able to tax, I was thinking your per capita, basically your per capita income, your GDP would reflect that. So I went and I got this data and put it into Excel. So let me show you a little bit about what that looks like. My data wrangling, cleaning, transforming looks like. So over here in Excel, get rid of that message. So I've got tabs here. The way I construct data is I try to not lose the raw data that I was working with. So I've got a lot of tabs here that I don't really need. I did all of my analysis with this clean table here. You'll see I've got the state names in upper and lower. I don't really need both of those, but I've got them. The official 2-digit code. And then I've got the 2019 population. And that's a full disclosure. The data for my project came from different years. So it's not like I can say I had access to crime data from 2020 and population in 2020 and whatnot. So in the real world, you'll want to make sure that if there are limitations to your data, that you explain those so that folks don't poke holes in your analysis. But for a practice exercise like this, just be aware these aren't necessarily the exact same years. I just needed notional data for practice. So I got the population, the state budget per capita. That's what started this whole curiosity, is how much a state government spends on each of its citizens on average. PCS's per capita spending I reduced it because the scale was so much different than some of the other stuff I was looking at, but that can affect your graphs. So I've got per capita spending, the crime rate per 100,000, the graduation percentage, and then the GDP is a currency field. So that's what it looked like after I cleaned everything up. But when I first got it, you'll see I got columns I don't need. Here's my crime rates per 100,000. I had a bunch of columns I didn't need, so I wound up just selecting the column and deleting it, honing it down to what I needed. Crime rate 2020. This is after I got it down to what I wanted it to, and I left the state because all of these tables would include something I didn't need, either Washington, D.C., or Puerto Rico, or the Marianas Islands, or all of the above. And I would have to go through, and all I'm looking at are data from the 50 states. So I would sort my main all data table in alphabetical order by state. And then when I got a nice clean column of data, I would sort that in alphabetical order so that I would make sure the appropriate data would go into the appropriate state. So I would just basically select the entire column of data and then paste it where I needed it. And I thought I had some really ugly raw information. Yeah, here you go. This is a table pulled out of one of my sources. And it comes in with these multiple header rows and columns you don't need and whatnot. This is the gross domestic product information. The state has this asterisk next to it because they've got notes in the table. So let me show you how I did this. We didn't cover this in the Excel worksheet, in the Excel workshop. But for example, you can grab a URL, any internet URL, and Wikipedia works especially well. Let me just copy that. And if I say data from web, if you haven't used this, it's pretty cool. And we click on that. Yeah, it's an external source. Let me be reckless. Go out to Wikipedia. So you paste the URL in, and all I've ever messed with is basic, so I won't click on advanced and go off script. So you click out, you put the URL in there, and Excel knows to go out and basically scrape data from the web that are in table forms. There's an HTML construct when you're developing a web page where you put values in a table and your browser knows to render it in that nice, pretty tabular format. So you can use that. Since HTML has formatting rules, Excel knows those formatting rules, and it can go in and actually extract the data from a table on a website, kind of scrape the data. Some people will use that term. And place it into Excel. It can be faster than cutting and pasting off the web directly out of your browser. So table one, it lets you preview, because web pages will often have more than one table. But what you really want is in the, in one table. So what we really want is on that Wikipedia page is this violent crime rate per 100,000. So if you see this preview and it's starting to look, hey, it looks reasonable. I got headers and I got values, and it doesn't look crazy or anything. You just click on load and it'll bring it right in like that. So like I said, you can cut and paste this stuff into Excel, but sometimes it's a little easier to use this one. So in my data cleansing, data wrangling, I had to do just a tiny bit of getting rid of extraneous headers, then getting rid of columns I didn't need, sorting, and occasionally I had to do the change to number format. Whenever I pasted the amounts in, I got that little yellow caution that we saw in the Excel workshop, and I had to click in the very top value. I had to click convert to number, and that's the whole paste. So that was my data wrangling phase, so that I wound up with a table of clean data pertaining to my business questions. Okay. Any questions so far? Sound good, Edgar? So far, so good?
I had to step away for a second, so I might have to watch the recording.
Okay, yeah, because yeah, I'm basically doing what I'm hoping that you'll mimic on Thursday. Okay, so after we get our clean data, then we run it through our analysis. So I was using continuous variables. There's there's other ways to compare something like what we've got, which are continuous variables, the columns, the GDP, the high school rate. Those are basically continuous values. And the way to look for relationships between two continuous variables classically is to look for correlation. So that's what I've got. So I went into my into Excel and created scatter plots for my three relations. So scatter plots are super easy in Excel. If you're not comfortable with Excel charting, an hour or two with our Excel 2019 Bible, there's a sample worksheets that have charts in them, and it tracks right with the book. And there's 2 chapters on charting and how to change the elements, change the color scheme, put in axis labels and all that kind of stuff, change the scale. So if you would like a refresher on Excel charting, I recommend that Excel Bible, a couple of chapters. So yeah, real quick though, if you want to check the correlation of two continuous variables, the x axis needs to be the left hand column. So I'll click on spending, which is our, that's our independent variable. That's what we were saying, per capita spending. So I'll use the full per capita spending in thousands. And then I wanted to look at, say, for instance, crime rate. So I'm going to hold control and click on that column. Now I have 2 continuous variables, an X and a Y. And if I just go over here to insert, and then this is the symbol for the scatter diagram. Not every graph works with every type of variable or type of comparison, but 2 continuous variables, your scatter diagram is your classic way to look at the relationship between those. So I went into Excel, created my scatter diagram. This plus sign gets you to the chart elements, which are the various things like the chart title, the scale, that sort of stuff, the grid lines. So you can modify the appearance of the chart greatly with these chart elements. I added the trend line, and then I wanted to add the more options. I wanted to add the especially the R squared value. That's the mathematical representation of how strongly correlated those variables are. So I went into Excel and I used it to do my chart elements to include a axis titles. And yeah, by default, you get axis title. It knows that X is spending per capita, but it tells me axis title by default. So yeah, so you have to click in there and change that. So yeah, I did these kind of things, nothing major, just a few, prettied it up with just a couple of things. And then I pasted into my PowerPoint so that we can look at it a little bit larger, a little bit cleaner. So here's your equation of our line of best fit. And you can see our R squared value is 0.0027. And as we know from before, R squared's got to be 0.5 or better to generally to point to a strong correlation. So 0.0027 is not correlated. And R square always comes up with a positive value. That's why it's used, so that even if you have negative correlation, if you square it, you'll get a positive value. But the R value here's negative 0.00. I mean, it's tiny, so it very loosely negatively correlated. So virtually no correlation between spending and crime in and of itself. So I thought, okay, well, is there a relationship between all this spending and the high school graduation rate? And it's a little more correlated, but negatively so. So your graduation rate is over here on the left. So it makes me wonder if states aren't spending more money to try and improve their graduation rate with more public spending. So I try not to look at, you know, which came first, the chicken or the egg. Try not to assign any sort of causation, because it could go either direction with this. Spending is high because graduation rates are low, or vice versa. So, but anyway, there's the your state spending per person on the x-axis. As it increases, generally speaking, our graduation rates go down a little bit. That, like I said, 0.11 is not a very high R squared score. Okay, so then I looked at per capita GDP, and again, very loosely positively correlated by using just pure mathematics. So my findings of my project were that there was no strong correlation among the variables I examined, and that's okay. You can get into a research project and discover, you can prove that there's nothing to see here, and that's okay. You may get pushback as an analyst. You may get pushback from maybe the marketing person was absolutely sure that that their whiz bang marketing idea was going to increase sales, but as the analyst, you have to stay neutral and try and avoid bias, avoid a situation ethically, avoid a situation where you're trying to make the data fit the conclusion that makes everybody happy. So, I mean, it can happen, but you generally want to try and avoid that. So I found there was no strong correlation among the variables, and we were looking at mathematically at continuous variables. But I went through the list and sorted the states by you know, the highest spending per person, which was North Dakota. You can see in the graph here, your highest spending dot on the right on the x-axis is almost $20,000 per person, and that's North Dakota. These 3-4 states far to the right of the x-axis are spending a good bit more than you can see. There's kind of a cluster of spending between, you know, $5,000 and $10,000 per person, with extreme outliers of heavy spending per person in some of these smaller states. So yeah, top spenders aren't generally very populated states, but they spend a lot per capita. Not sure what to read into that. I don't read anything into it. It's just there's the data. So yeah, like North Dakota, Oregon, Washington, Wyoming, none of those are particularly densely populated. High crime area. Yeah, I didn't realize this, but Alaska, very few people, but apparently they're all fighting each other and shooting each other and whatnot. And New Mexico, I knew that I'd lived in New Mexico. I'd lived in Albuquerque. I knew it had it. And Albuquerque's the one big town in New Mexico. But look at that, Arkansas, number 4. High school graduation rates. These are the best as at the top. So the top is Iowa, and we are not in the top 10. You'll see. And then per capita GDP. This is also highly reflective of the economy and whatnot. So yeah, New York, Massachusetts, Boston, New York City. This is Washington State, which I guess the Seattle, Tacoma, whatever you call that, Redmond, Silicon Valley North, sways that. And of course, California, Connecticut's fairly wealthy. But yeah, check out North Dakota, number 6 per capita GDP. I don't know if that's the sand oil fields that's affecting that, or that's not something I would have expected. So anyway, there's your top 10 lists, and that comparing ranked lists is another. If you can't get to the raw data as to what makes them ranked, you can still compare ranked lists. And there may not be underlying data. There may be a poll on social media where people say, you know, what are the 5 most trustworthy banks? And they list their top 3 most trustworthy banks or top 5. You can compare those lists and get a correlation score. There's a model called Kendall Tau that looks at 2 lists of ranked values and provides a -1 to +1 score. So there's more than one analytical model, more than one way to look at this stuff. But I figured that was good enough. But I wanted to highlight where Arkansas was. I sorted and found Arkansas's ranking. So we're number 7 in per person spending, right around 10,000. So we're a little bit to the right of that cluster in the middle. Fairly high crime, absolute middle of the pack when it comes to the high school graduation rate. And as I'm sure you know, Arkansas is continually 48th, 49th in most economic measures like GDP or poverty rate. We're consistently along with like Mississippi, Louisiana. Yeah, so lots of opportunity out there. But that was my data analysis project. And I would like for you all to emulate something like that. Like I said, it can be sports, it can be entertainment, it can be public policy, it can be anything, gee whiz, something at work. But I'm setting aside 3-4 hours to go through and what I did. And if yours isn't as pretty as this, you know, don't sweat it. If you want to do the whole thing in Excel, just clean it up as much as you can, kind of like, you know, copy and paste your charts onto a separate tab. And if you need to do like an arrow or a shape to point to something, to call out something, you can do that in Excel too. But yeah, so basically use Excel to answer a gee whiz question and something that you're curious about, something that interests you, whether it be professional or personal. Okay. Any questions, concerns?
When are you going to want us to present this?
Yeah, let's take the rest of the day today and like the first hour Thursday morning. You know how life happens sometimes. So everybody's scheduled to start at 8:30 on Thursday morning. So let's start at 9:30 on Thursday morning presenting. We should be able to knock these out in an hour or so. And then I want to move into relational database and SQL Thursday afternoon and for the next couple weeks. Any other questions, concerns? Kevin, you know what I'm looking for?
Yes.
Edgar, you good to go?
Yes.
Okay. Like I said, if I skipped over anything at the beginning, it'll be on the recording. Alyssa, Jeanette, I know you're kind of jumping right into the deep end of the pool, but is this something you're comfortable with?
Yeah, it looks good.
And Jeanette's there with you still, right?
Yes.
Okay. All right, guys. So like I said, we'll reconvene. I'll shoot an email out to everybody. We will reconvene at 9:30 Thursday morning. Be prepared to present these. So if there's a weakness in your audio capability, try and cure that up by the time we meet Thursday morning, so everybody can understand you real clearly. But yeah, the objective is twofold. It's to get you into Excel and hacking around and make sure that you're good with that. And if you have any questions or concerns, let me know. And it's to present, because the folks that can get up in front of the conference room and eloquently walk through an issue like this are going to hold more influence than those that can't. And that is just the way business communication works, in my humble opinion. All righty, guys. We'll see you back at 9:30 on Thursday.
All right, thank you.
Holler if you need me, as always.
Thank you.
Thank
Sure
you.
thing.